Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapters of resistors, electric power and energy, and AC voltage. This exercise was a previous one in the brevet exams in 2010 second session, second exercise. The title of this exercise is electric water heater. An electric water heater that can be considered as a resistor of resistance R is equal to 45.2 ohms is fed by the voltage U of the mains. The adjacent figure, they mentioned this figure, then now we can use it. The waveform of U takes square root of 2 is equal to 1.415. Now, the trick in solving such type of exercises is to determine the values of x and y, in which x represent the number of divisions along the x-axis, in particular between two consecutive peaks. This peak is positive and this peak is negative, then we cannot consider counting the number of divisions between these two peaks. Then let's choose point from the center, the first point, skip a point, and in this case the number of divisions is given by 1, 2, 3. Then in this case the number of divisions is given by 10 divisions. And now let's count the number of divisions corresponding to y, which is from the center to the maximum point reached by the curve. So this is 1, 2, 3, and this point corresponds to the first subdivision, knowing that each subdivision is given by 0.2. Then the value of y in this case is given by 3.2 divisions. Now part 1. Study of the voltage U. Number 1. Name the type of the voltage U. So here this axis is labeled by time and this is labeled by the voltage U. So here it is positive and here it is negative, so it's varying with respect to time, and it's alternately positive and negative. And the shape of this voltage is sinusoidal, so it is AC sinusoidal voltage source. Here no need to justify. AC sinusoidal voltage source. Now into part A, they are telling me to determine the maximum value Um of U and deduce its effective value U. Then Um is given by SV multiplied by Y. Now here SV represents the sensitivity along the vertical axis. So this is the vertical axis. So let's write here that SV is equal to 100 volts per division. And the horizontal sensitivity, this is the horizontal sensitivity or the horizontal scale, is given by 2 milliseconds per division. Knowing that millisecond is not the SI unit of time, in order to convert from millisecond to second, we simply divide by 1000. Then dividing 2 by 1000, we will get 0.002 seconds per division. Now the value of SV is given by 100 and the value of Y is given by 3.2. Plugging this on the calculator, it will give me 320. Since everything in the SI, so the value of Um will be in the SI, which is volts. Then Um is equal to 320 volts. Now in the same part, they are telling me to deduce its effective value U, which is given by U effective. Knowing that U effective is related to Um via the following formula, U effective is equal to Um divided by square root of 2. Now the value of Um is given by 320 and the value of square root of 2 is given 1.415. Plugging this on the calculator, it will give me 226.15. Since the unit of is volts, so the unit of U effective will be volts, which is the SI. So the value of U effective is given by 226.15 volts. Now in part B, they are telling me to determine the period T, which is given by SH multiplied by X. Now the value of SH and the SI is given by 0.002 and the value of X that we already determined is given by 10. Plugging this on the calculator, it will give me 0.02. Since both SH and X are in the SI, so the value of the period will be in the SI, which is seconds. Then the period is given by 0.02 seconds. And now let's deduce the frequency f, and deduce means that we need to use the part just previously before. We already determined the period, and we know that the frequency is related to the period via the following formula. So 1 divided by 0.02, plugging this fraction on the calculator, it will give me 50. Since the period in the SI, so the value of f will be in the SI, which is hertz. Then the frequency is given by 50 hertz. Now, part 2, monthly consumption of the water heater. The water heater is used at the rate of 6 hours per day. Then the time for 1 day is given by 6 hours. Now, part 1, they are telling me to determine the effective value I of the current through R. So through R, we know the value of the resistance R, and we already calculated the value of the effective voltage, which is given by 226.15. Then we can determine the value of I using Ohm's law. Then let's apply Ohm's law to the water heater, or let's say, okay, to the water heater. Here, in other words, we are applying Ohm's law to the resistor R. Ohm's law is given by U is equal to R multiplied by I. Constructing the triangle of this formula, since we have multiply, then U will be at the top, R and I at the bottom, in which we are interested in calculating the value of I. Putting our hand over I, then I will be given by U effective. So here for sure I effective divided by R. Okay, so they labeled I to be I and not effective. So U effective is given by 226.15, and the value of R is given by 45.2. Plugging this fraction on the calculator, the value of I is given by 5. Since U and R are in the SI, so the value of I will be in the SI, which is amperes. So the value of the effective current here is given by I is equal to 5 amperes. And U effective is given by 226.15 volts. So here also they labeled U without the effective, but it's okay. Now in number 2, they are telling me to determine in kilowatt the electric power consumed by the water heater. So here it seems that we are calculating the electric bill that consists of 4 steps, and they are given by step number 1 to convert or to calculate the power in kilowatt. Step number 2 is to calculate the daily consumption, which is given by E1 per 1 day. Then step number 3 to calculate the monthly consumption, so for 1 month. Then step number 4 is to calculate the monthly cost. Okay, here we need to determine the electric power, which is given by P is equal to U times I. Now the value of U is given by 226.15, and the value of I is given by 5. Plugging this on the calculator, it will give me since both U and I are in the SI, so the value of P will be in the SI, which is watts. Then the value of P is given by this. Now here they are telling me to determine the value of the electric power in kilowatts. Knowing that to convert from kilowatts to watts, we simply divide by 1000. So P, which is given by this, now dividing by 1000, then the electric power is given by 1.13 kilowatts. Then in this case we are done with the step number 1. Now in number 3 they are telling me To calculate in kilowatt energy the electric energy consumed by the kilowatt hours, the electric energy consumed by the water heater in 1 day. So we are in step number 2. The electric energy is given by E is equal to P times T, which corresponds for 1 day. Now kilowatt hours can be decomposed into kilowatts multiplied by hour, which means that time must be in hours and the electric energy in kilowatts. So the value of the electric power of this water heater is given 1.13 and time is given by 6 hours. Now plugging this on the calculator, it will give me 6.78 and the unit is given by kilowatts hour. Then the electric energy E1 consumed per 1 day is given by 6.78 kilowatts hour. And now we are done with the step number 2. Part 4. They are telling me determine the monthly cost to be paid by the consumer using this water heater, knowing that the average price of 1 kilowatt hour is 100 Lebanese liras, take 1 month is equal to 30 days. So in order to determine the monthly cost, which corresponds for step number 4, we need first to determine the monthly consumption. Then let's determine the monthly consumption. Denoted by E, which is equal to E1, the energy consumed per 1 day times the number of days, which is equal to 6.78 multiplied by 30, because the number of days is given by 30. Plugging this on the calculator, it will give me 203.4. Since E1 is in kilowatt hours, then E will be in kilowatt hours. Sorry. Now the monthly cost is simply E times the price. The electric energy consumed per month is given by 203.4 multiplied by the price, which is given by 100 Lebanese liras. So the monthly cost is given by 20,340 Lebanese liras. And by this we have finished solving this exercise. I hope it was beneficial for you guys out there watching it, and see you soon in another one.